Hello, my name is Preeti Shinde. Title of my presentation is Preparation of Sustainable Release Mesoporous Silica Nanopesticides for Control of Monocomus alternus. In this presentation, we will cover following points: introduction, research background, result, and conclusion. Before knowing to the solution, let us know what is the problem. Monocomus alternus is a stem borer that endangers economic and ecological forest. They feed on the branches and leaves, bores onto the xylem, leading to the gradual death of trees, causing a cancer disease called Buryrophilus xylophilus. It is a main vector of pine wilt disease, a significant forest quarantine disease. There are several measures of chemical pesticides, biological methods, which are constantly optimized to stop the outbreak caused due to it. There are various types of pesticides present in the market like biopesticides, chemical pesticides, plant-incorporated pesticides, biochemical pesticides, etc. But due to the various traditional and conventional methods of pesticides, they create environmental pressure due to the excessive use. They have problems like residue, residence, carcinogenicity, mutagenicity, etc. Thus, there is a need to develop smart technologies for modern agriculture with high efficiency, safety, and environment protection. Nanotechnology has been gradually applied for different nanomedicine, nanotechnologies, etc., and now it is used in agricultural as well as forest pest control. IUPAC has rated nanopesticides as the top 10 emerging chemical technologies that will change the world. Nanotechnology showed great advantages of stability, delivery, biocompatibility, bioavailability with high surface area and volume, etc. There are various types of nanoparticles used in drug delivery system, and in this research we will be using dendritic mesoporous silica nanoparticles because they show excellent biocompatibility, biodegradability. They have high surface area with uniform pore volume and pore size. They are stable, non-toxic, easily functionalizable, excellent drug carrier with high loading and release capacity. In this research and experiment, we have used ivermectin as a drug to treat the side effects caused by the monocomus alternus. Ivermectin are a group of drugs that occur naturally as a product of fermenting Streptococcus ivermectin as an actinomyceticide isolated from the soil. AVM is a broad-spectrum drug and it's globally recognized biological pesticide with the largest production and use. AVM is usually used as an insecticide that has stomach toxicity and contact toxicity. It also easily decomposes with the sight of light. In this research, DMSNs are utilized to encapsulate the AVM to control monocomus alternus, a major vector insect of pine wilt disease. The research background: here ChemE-Tube was used as a surfactant or templating agent which forms a micelle-like structure. Later, TEOS was used as a silica source and the template was removed by using concentrated HCl. The drug was loaded onto the silica nanoparticles by making a concentrated saturated solution of AVM into methanol and mixing nanoparticles to it. The drug loading efficiency of the drug was calculated using the formula as shown here, that M1 minus M2 divided by M0 plus M1 minus M2 multiplied by 100. The synthesized material was characterized by different characterization techniques like same-time analysis, and the results are interpreted as below. From the results, we came to know the size of DMSNs is about 200 to 250 nanometer, which are uniform in size and well dispersed. Later, the DLS analysis was performed to know the average particle size of DMSNs, which was about 317.14 nanometer in a dispersion and also shows a normal distribution. The stability of the dimensions of DMSNs was also measured up to 7 days, and it was found in previous for solution of pH 7.4. Later, the XRD analysis was performed to know the lattice parameters structure of the material, and the peak at 22.3 indicates that synthesized material is amorphous in nature and stable. FTIR, that is Fourier transform infrared spectroscopy, was performed to detect the functional group present on the synthesized material, whereas the spectrum A, which is of drug, shows the peak at 1735 of carbonyl and peak of alkyl at 2968 cm inverse, whereas the nanoparticles shows the peak at 1096, which is of silicate framework. Similarly, the drug-loaded nanoparticles shows peak of both the materials of drug as well as separate material, that is carbonyl group at 1735 cm inverse and silicate group at 1096.87 cm inverse. The BET analysis was performed to know the surface area of the material, and from the nitrogen adsorption analysis, the DMSs shows typical 4 type of graph, which shows that the synthesized materials is mesoporous in nature. And from the analysis, the specific surface area was calculated to be 3355.96 meter square gram with a pore size of 10.15 nanometer and pore volume of 0.844 cm³ per gram. Finally, the loading and release of AVM at the rate DMSNs was performed. Loading of DMSNs was calculated to be 85.73, whereas the loading efficiency of the AVM was calculated to be 68.8%. The drug release was calculated in different pH solution with constant time and temperature parameters at different certain intervals of time, and it was found that the maximum drug was released at pH 8.2 than the pH 5.2. Also, the drug showed a stability for several hours, which showed that there is a controlled release of drug. As we know, the AVM is a photosensitive material. It was necessary to check the photosensitivity or the photodegradability of the AVM loaded DMSNs, and from the results it was shown that the decomposition curves under UV and dark conditions both illustrated protective effect of DMSNs on AVM. AVM decomposed about 50% within 3 hours, while AVM loaded DMSNs decomposed only about 4.5%. Later, it is very necessary for a nanoparticle to show minimum side effects and less toxicity. Hence, it is necessary to see the degradation properties of DMSNs, and it was seen that as the material was kept in different pH solutions for several days, the DMSNs completely degrade at pH 8.2 in 28 days. Biodistribution and cellular uptake test is a fluorescent experiment performed to check the transmission of the drug material into the epidermis as well as the stomata, and it showed good results due to the small size and uniformity, and concluded that FITC loaded DMSNs smoothly transported through the intestine through feeding on the basis of AVM transmission. Later, absorption, transmission, performation, evolution. It is necessary to consider absorption capacity of AVM loaded DMSNs NPs in trees to exert its efficiency. Here, the drug-loaded particles were injected into the tree by drilling holes and injecting drugs and observed at different time intervals. It was observed that fluorescent distribution intensity gradually decreases through P direction. Thus, FITC loaded DMSNs had shown good transmission procedure, and after several time, the absorption capacity of AVM at different concentration varies slightly with increase in concentration. Different factors of growth of tree development affect the transmission of the drug. Conclusions. From this paper, we conclude that DMSNs prepared by one-pot method had uniform size and good dispersion. Thus, the synthesis process is simple, convenient, and saves time. DMSNs played a role in physical isolation, weakened the intensity of UV light, and improved the photochemical stability of AVM. Also, the efficacy of the drug was improved and is longer than the original drug. Biological activity and control efficiency of AVM is also improved. Pesticide sustained release system was developed successfully by loading AVM with deaminations. Thus, this paper provides scientific control information of monogamous alternate xylophyllus in forestry. Thank you.